This sheet is combinations starting for us. So if you read through the instructions, it gives you a suggestion. It says to use the first index law, which we know is about multiplying powers, to simplify the numerator, which is the top part of a fraction, and the denominator, which is the bottom part of a fraction, separately. So it's saying to work out the numerator and the denominator separately using index law 1, and then use the second index law, which is the law of division of powers, to finish the question. So I'll just rewrite our A question down here. So if we look at the numerator first and we follow our rule of keep the base and add the powers, we simplify this part of the question from 2 terms to 1 term, because we're all about simplifying. So that becomes x8 for us by keeping the base and adding the powers. And the denominator becomes keep the base, add the powers, x, and add our powers for index law 1. So now you can see we had an expression that had 1, 2, 3, 4 parts or terms to it, and we've simplified it so far to an expression that has 2 terms. Now with our division, we know we have to keep the base and subtract the powers. So our answer becomes x squared, because we kept the base and we subtracted 8, take away 6, our powers. So it's combining 2 index laws now, index law 1 and index law 2. This one is if we keep the base and we add the powers of 3 and 4 gives us 7, and 5 gives us a to the power of 12, divided by a to the power of 3 down here, remembering that is really a to the 1 here. So we keep the base of a and add the powers. So we've applied index law 1 to simplify it to this point. We can keep simplifying because we see it's the same base, keep the base, but this time we would subtract the powers. 12 take away 3 gives us a to the power of 9. It had 1, 2, 3, 4, 5 terms, and we've simplified it to 1 term. We can't solve it, we don't know what A is, but we can definitely simplify things. This one I'm going to choose to keep this 12, which is called our pronumeral, and we have some pronumerals in the denominator as well. Question A and B only had bases and powers. Keep the base, add the power, keep the base, subtract the power. Question C, as you can see, has some pronumerals. So let's work through our numerator, 12. If we keep the base of A, A3 is going to go with A2, so keep the base and add the powers. 3 plus 2 gives us 5. Our B's, we have B to the power of 1 there, and B to the power of 3. Okay, so down the bottom, 6 multiplied by 2. Remember, you have to multiply your pronumerals. So 6 times 2 gets us to 12. Now we've got a squared and a to the power of 1 there. So we've got a to the power of 3. B to the 1, B to the 2 is B3. We can keep going here, because if we look again at our pronumerals, 12 divided by 12 gives us 1. So in the test, pronumerals, 12 divided by 12 gives us 1. If you actually wrote the 1 in the test, that would be fine, but most mathematicians would just say that they cancel each other out. 12 divided by 12 is going to give us 1. Okay, so now we can just look at simplifying the rest. keep the base, so we'll focus on our A base. 5 take away 3 for our powers gets us A squared. B4, B3, so we're going to keep the base and subtract the powers. 4 take away 3, again you could put a 1 there. So in the test, if you ended up with 1A squared B1, it's exactly the same value. Okay, you'd find a textbook or a mathematician leaving it like this and not writing the 1 at the start or the 1 at the power, but that would be fine. This one here, okay, this one has a pronumeral in the denominator, so it's going to have to sit there because there's no pronumeral in the numerator to divide it. So we're going to keep the base of k to the 2 and add the power. So remember, that's a power 1 over here. So we have k3. J and j squared, we have j3. And we have just j and k squared down the bottom. Oh, hang on. 4 times 2, that should be 8. Multiply your pronumerals to give us 8. Okay, we have a single j and a k squared. Alright, so we're going to have to leave it as a numerator and a denominator. But we put our variables on top. A, B, C, D, E, F, G, H, I, J, K. So we're going to have to put our J's first and then our K. And then our 8's. So that's from the other question. Our 8 is going to have to stay sitting as a denominator in this question because we can't simplify it. There's no numerator except for 1. So if we look at our J's, we got j3 and a j, so we're left with j squared, j to the power of 2, and here we have k3, k2, so it's k to the power of 1. So alphabetical order, j squared and k really to the power of 1 over 8 is our answer there. Alright, this one, let's look at our pronumerals. You might decide to, I don't know, I'm going to leave the 8 there for now and just work through my x's, x7 and x3, so I'm up to x10, and y6 and a y1, so I'm on y7, divided by 2, leave it for now, okay, 2, okay, x3 is all by itself there, and then I've got y and y3, so I've got y4. Right, now you might go 8 divided by 2 actually gives you 4. 8 divided by 2 gives you 4. Keep the base, to subtract the power. So we've got x here, keep the base. 10 take away 3, subtract the powers is 7. Okay, keep your base as y. Subtract your powers, 7 take away 4 is 3. Okay, last question. So we have quite a few pronumerals that we might simplify into 1. So we've got 5 times 2 is 10. 10 times 6 is 60. Okay, 60, and then we have all c. So we have c to the power of 9. Alright, that's divided by 3 times 2 as our pronumerals. Okay, 3 times 2 is 6. Now we have bases of c down here as well, so we've got 4 and 2 is 6 and 3 is 9. Okay, I see. Alright, so then we can probably see that the C9s can just be cancelled out. Then you're just left with 60 divided by 6 to give you 10. Okay, if you want to prove that a bit further, I guess you could go 60. And then you're going to go, well, I want to keep the base and subtract the powers. So C, let's keep the base and subtract the powers. 9 take away 9 is 0. And our 6 was on the bottom. Okay, so if you want to look at it this way, you could go, well, it's 60 multiplied by c to the power of 0. We should know that anything to the power of 0 gives us 1 divided by 6. So we're still left with 60 divided by 6 to get us 10. Okay, so the little revision cue here was I had c to the 9 and c to the 9, and you can just cancel those out and say one's on the top, one's on the bottom, so there's nothing left. Okay, if you want to prove it a bit further, you can go through and go, well, no, I want to keep my base and my powers happening, so it's going to end up c to the power of 0, because 9 take away 9 is 0. And then you should see then that anything to the power of 0 gives you a value of 1. So you end up with 60 divided by 6 anyway to give you 10. Just the same as we did up here when we just cancelled the C9s out.